All right, let's take a look at homework 6B. In this homework and the following questions, we're going to be dealing with impulse, force, and change in momentum. So we're adding on to our basic definitions of momentum, adding kind of an impulse momentum theorem, being able to go back and forth between units like newtons, and the force that results in newtons, change in momentum, being able to use velocities, changes in velocities to calculate changes in momentum, using that to calculate force. We're going to be able to go back and forth, and that's what we're working on in this particular homework. So, as we have an existential crisis on the screen there for a second, sorry about that. A 0.5 kilogram football is thrown with a velocity of 15 meters per second to the right. A stationary receiver catches the ball and brings it to rest in 0.020 seconds. Okay? What is the force exerted on the ball by the receiver? So a couple of things I know. I know the mass. I know an initial velocity, and I know a final velocity, and I know a time. So I have 4 things given to me by the problem. What is the force exerted on the ball by the receiver? So we want to get a force calculation out of this, right? Our final answer is going to be a force. Now, if you've been following along with the introduction of momentum, right now, as it stands, I can do a calculation to figure out what the momentum is, or more specifically, the change in momentum, because I have a mass and I have 2 velocities. And yes, that object goes from this initial velocity to this final velocity. So I can do a calculation of impulse. Remember, impulse is the change in velocity. Now remember, velocity, what the heck? Change in momentum. I'm saying random stuff here. Momentum is mass times velocity. But here in this specific instance, when we're dealing with impulse, right, because we're going to use our definition of impulse to get to force, okay, we're going to use change in momentum, not just regular momentum, just pure momentum, instantaneous. We're going to use change in momentum, so that's going to require us to use a change in velocity. Well, perfect. We have that in the equation. So I can calculate the change in velocity pretty darn easily. Change in velocity is equal to the final velocity minus the initial velocity, which is equal to 0 meters per second minus 15 meters per second, which gives us a change in velocity that is equal to negative 15 meters per second. Now, this is not the answer, but this is what I can do to get a value to plug in for change in velocity, which will give me change in momentum, which is impulse. So, change in momentum is equal to mass times change. I always mess up. Change in velocity, which is equal to 0.50 kilograms. And then I just calculated that the change in velocity is negative 15 meters per second. And so my change in momentum is going to be negative 7.5 kilograms meters per second. So I've just calculated a change in momentum. That is not, remember, that is not what the question is asking for. The question is asking for force. But again, I calculated the change in velocity, so I can use the change in velocity to get change in momentum. I can use the change in momentum to use my definition of impulse, which is where I come in here. Impulse is equal to force times time. Force times time. And so another way to rewrite that is now this question is asking me to solve for force, so I'm going to divide both sides by delta t, and so the equation that I'm actually going to use to plug in chug is going to be force is equal to change in momentum there, impulse, divided by delta t. Well, I've calculated an impulse, delta p, and I was given a delta t by the question, and my calculator wants to spit out negative 375. Now we have seconds canceling out seconds, so the units here are going to be kilograms times meters. But remember, a kilogram multiplied by a meter is a newton. Now my calculator spits out 735. I want to round this to 2 sig figs, right? Because 2 sig figs, 2 sig figs, 2 sig figs. So I'm going to round this to, what am I going to round it to? Negative 380 newtons were applied to the ball by the receiver, but in the direction opposite of the path of the ball. So if I want to be super correct, I forgot to put in the direction. Let's comma to the left. To the left. Now I've got everything I need here, right? Because the ball was moving to the right, so in order to apply a force to it to get it to stop, you got to apply a force to the left. That's going to be a value of 380. Now that I'm looking at it, how about this? Let's ignore that negative 380, and we'll just say to the left. Or I could write negative 380. That way I could ignore to the left, right? Because that negative sign actually is a direction when it comes to physics. So yeah.